thrust, remember that this is coastal weather surveillance and forecast systems. So we're not dealing with the ocean part. That is another cluster. So we're mainly going to be talking about the weather. We are in some ways the largest group, and so we're kind of a big chunk of the ERC. So we have an important mission. I think being able to convey some compelling ideas of why we should be funded is going to be very important for the success of the whole ERC. So again, our group is called the Coastal Weather Surveillance and Forecast System. So it's a combination of models and sensing platforms focusing on the environment. So I wanted to start with each of us going around, maybe telling us about their quickly name, background, expertise for a minute, and then the aspiration of what you want to get out of this ERC in terms of what are your main research interests to do through this ERC. So maybe Nathan, sorry to put you on the spot, but you're the first one I have here on my list. So do you want to get started?
Okay, absolutely, Ellie. Hello, everyone. This is Nathan Hosanna. I am formerly of City College, but still of the City University of New York. I'm an assistant professor at LaGuardia Community College. My focus is convective processes and their impact on precipitation, both in the urban environment I'm interested in, and I've been doing extensive work in the Caribbean. But I'm also interested in the aerosol impact as well.
And what is your hope for this ERC in terms of the things you want to focus on in this ERC? I guess, is it the same type of questions in general, or is there anything new?
So it is the same type of questions, but I also think that since my work has been focused in the Caribbean for the last, I would say, 5-6 years, that it would be kind of interesting to look at some new environments as well. So I'm here to listen. I'm here to understand what you guys are doing and to offer support where it makes sense and fits.
Okay, sounds good. So before we proceed, Pratap, can I bother you to take some notes, because I'm not good at multitasking. I can't.
I will. I am actually taking notes, Ellie, so don't worry.
Okay, perfect. Thanks, Pratap. So, Reza, do you want to tell us about your background and interests?
Sure. I'm at City College. I'm the civil engineering hydrologist. So my interest on the urban area is more in terms of the flood forecasting and flash flood warning. And this include a number of things that we have or asset that we have. We have about 20 stations in New York City metropolitan area that has a small weather station that measures rainfall or precipitation, soil moisture, temperature and humidity. Plus, we have also part of the NOAA CREST Center that we have here. We have things on the roof of the buildings that they have a large data set. So we have ground data set. We also have some satellite data set that comes from NOAA and also radar, the two sources of the remote sensing data set that we have. That those combined with some modelings that we have been engaged in it or give us some tools for urban flood kind of the model or alert system. If you want to call it more, it's more like a alert system, because we have to put topography and the drainage and things on it.
Okay. Reza, are you still the director of NOAA CREST formally, or is NOAA CREST still a thing? It's still going on, right? Okay.
Correct, yeah.
Okay.
We are on our 18th years, but it's still kicking.
Okay. I guess everybody knows what NOAA CREST is. I don't see, given the participants. Jim, do you want to say a couple of words?
Yeah, this is Jim Smith from Princeton in Civil and Environmental Engineering. My interest is hydrometeorology of extreme rainfall and flooding in urban environments is one setting. The other that we've been working on a lot in recent years is coastal flooding or rainfall flooding in coastal regions and falling tropical cyclones. The New York City area is one of the areas we worked in, but also Houston, the two hurricanes that have affected North Carolina. I'm working a lot with polarimetric radar from the operational network and with atmospheric modeling of urban rainfall and tropical cyclone.
Okay. Pratap?
Hi, everyone. This is Pratap Ramamurthy. I'm an assistant professor in mechanical engineering at City College. So my research is in understanding like urban climate in general, and I've been doing quite a bit of work recently on studying like coastal urban, the impact of coast on like mega cities in general. So my thing, like in respect to this ERC that I want to see is like in general, like what happens during all these extreme conditions. Like, you know, most of my work right now is focused on mostly normal situation or maybe during extreme heat. But however, like what happens, you know, during a storm is something like it's one of the personal interests for me to be involved. I do a little bit of modeling, and I also have a big like weather network that Reza said, like I've been using it quite a bit. We also have a lot of capacity right now with the new Mesonet in NYC, and City College have access to a lot of this very high resolution, like lower atmosphere observations. We also have like a network of now 5 to 6 flux towers in the city. So that's something of interest to me. The other area that I'm also currently I'm working is like how to incorporate like remote sensing data into to understand or to advance like urban climate processes in general. So like Reza said, like I've been using a lot of these new geostationary data sets and then making them more applicable for urban areas, particularly understanding the surface energy budget. So in terms of ERC, I think like how we kind of like couple with other groups, for example, like people who are doing a lot of this ocean scale stuff and also the ecosystem processes is going to be, I think, one of the biggest challenge for us, like how we integrate with other folks. Thank you.
Okay, thanks, Pratap. Mark?
Okay. Yeah, I'm Mark Arend. My research thrusts have been a lot geared toward ground-based optical remote sensing using various different types of phenomenology from radars as well as LiDARs, and I've also done a lot of my own development of sensor systems. And for this ERC, where I'm seeing that one of the questions I think that we really need to address is what sort of industry is going to evolve out of this. And I'm even taking from the point of view of the other ERC that Princeton actually led, that Ellie and I think Jim, you were involved in Mirth also, right? I think, but I know Ellie was, but you know, to try to understand, you know, now actually as we're bringing what we're seeing in the future of how this surveillance systems and sensing systems can now be kind of integrated together to be able to form a more sort of synergistic sort of collective system from different phenomenologies, and then to try to understand, like in the future, like what sort of going mobile with various different types of ground-based remote sensing LiDAR systems and radar systems, and not just ground-based, but mobile on the ground and mobile with what's actually really happening, I think, is going to be putting more of them on aerial systems. So this is kind of how to go into the future. That's kind of how I'm seeing of bringing what I've been doing going into the future of what could be sold into a good ERC is to bring like a multi-sensing platforms that can cooperate and be mobile both on the ground and in the air.
Yeah. One of the companies, sorry to make a little intermission, one of the companies we should chat with is, given your interest, Mark, is Amazon, with all these drones that they want to start delivering products with them everywhere, and whether they'd be willing to collect some meteorological data. I think that might be something interesting we can brainstorm about. Okay, thank you, Mark. Now, so 5 people discussed or introduced themselves. I'm the 6th. I see we have 10 people on the conference call, so there's 4 people I missed. I see one of them is Fred. Fred, do you want to introduce yourself and tell us about your past and future interest in the context of the ERC? Maybe Fred is not. So who else? Rafael, I see that you're also joined. Do you want to introduce yourself and tell us about your past and future interests?
Sure. Sorry, I had mine on mute, but I'll wait for Rafael to go first.
No worries. Rafael, go ahead.
Can you hear me, guys?
Yes.
Okay. I'm Rafael Rodriguez. I'm a professor from electrical engineering at the University of Puerto Rico in Mayagüez. My work has been mostly in antenna design and microwave sensor design. So one of my interests here is to design very small radars that can be distributed to do some of the meteorological measurements required, and to see how those can be also put into different type of platforms like drones and etc. We're working right now with doing passive sensor radiometers for measuring ocean salinity and soil moisture to be put into drones to the CREST program. So we'd like to expand a little bit of that and doing that active sensor as well.
Okay, thanks, Rafael. Fred?
Yes, my name is Fred Moshari. I'm from electrical engineering at City College, and my work has been primarily on atmospheric remote sensing. Have focused on both weather and air quality applications. Clearly, I guess air quality episodes is an area that we've worked on before, ozone and particulate pollution and precursors, and also some severe weather work using the various ground-based and satellite-based remote sensing to look at weather patterns and particularly winds, in a local and regional setting. And so in that sense, the kind of severe weather applications are air quality and heat waves and storms, certainly, and I can collaborate and work with people along those 3 teams.
Okay, thanks, Fred. Who else did not introduce themselves? Who else is on the call and did not introduce themselves?
Hi, this is Rafael. Jonathan had joined and had some problems with his connection, so he's coming into my office. So I think I'll be expecting him in the next 2 minutes or so. I'll let you know when he arrives.
Okay. So I can introduce myself. I'm Elie Bouzed from Princeton, Civil and Environmental Engineering. My main interest is in urban modeling, if you want, flow in urban areas. So part of what I will do through this ERC is maybe to kind of try to think about the classical type of models like WRF and maybe more fast models that can integrate the data for fast prediction in urban terrain. And also one of the projects that I've been interested in recently is mobile sensing, but these are ground-based sensors mounted on cars or buses. And then how to fuse the modeling and experimental data, create maps of environmental conditions in cities, and then develop apps or other type of platforms that are easy for citizens to access and understand their urban environment. So I've been interested in this kind of communication aspect of coastal and urban data to citizens. So I'm a little bit flexible. I haven't decided exactly where I would, what I will put my focus in as part of the ERC. It depends, I guess, on the needs. So now that I think everybody has introduced themselves, I noticed that there's more of an observational tilt. There's still a bunch of modelers, but I think there's more observationalists or experimentalists than modelers. So that's something to keep in mind. Now, so after that,
Ellie, but one thing, Jorge obviously is a modeler as well.
Yes.
So we do have another modeler.
Yeah. No, I think Pratap and Jorge and Jim and myself, we all are kind of modelers. Yeah.
Yes.
So we I'm not saying but yeah. So the next thing I wanted to remind everyone of is the global mission of the center. So I'm quoting exactly from the slides. The center will enable the next generation integrated community scale alert and guidance and planning system to secure coastal habitation when subject to extreme weather scenarios through real-time adaptable response architecture. And one of the comments in the reviews that was kind of a weakness we should address is that we talked quite a bit about the alert and guidance and warning, but then we didn't talk a lot about the last aspect, which is real-time adaptable response architectures. It's not clear what we mean by it, but one of the questions or one of the comments of the reviews we should keep in mind is that, okay, so we alert the people that there's, an extreme event coming, take shelter, get away from the coast, don't go outside if it's too hot. But then what are we going to do about making maybe coastal communities in the long term more adapted or more resilient to such extremes? And this is something we kind of have to keep in mind as we develop this. Also, another thing I was thinking of, Masood and Jorge are not here, maybe we can discuss that tomorrow, is that the observational components, which is the observation and modeling of the atmosphere component, and the observation and modeling of the ocean component, which is another thrust, we're kind of the core of the effort, and as such, it falls, I think, on us to reach out to the other thrusts and integrate them. So the other thrust, let me go back to the slide. For example, they would be, let me see what slide I should be looking at. So we have data integration, dissemination, and distribution. We have another thrust on innovation ecosystems. I think we should try as much as possible to reach out and try to provide our products to the other thrusts and make sure that we are linked to all these thrusts, because in a way what we are doing is the first and central product, and everything else builds off of what we are building. So at some point, maybe not today, but at some point in the near future, I would like for us to have kind of coordinator with each of the other thrusts. That coordinator will also maybe participate in their Skype calls and meetings and would be able to help us bridge and coordinate to have a cohesive proposal. Does that sound reasonable to everyone?
Yes, Ellie, I think we actually did something similar for one of the previous proposals. Like, we had people from different groups, like, one of them will mingle with the other group, and then they will make sure, like, they will update them, and then they will take it and then feed back to their original group and so on. I think that's a good idea. We should definitely do that.
Okay, perfect. So maybe we can do this across all thrusts to make sure we have communication during the proposals. Okay.
Yes.
So the next agenda item I wanted to get to is what are the risks? So our cluster is about weather risks, and I sent a link with some any other thoughts about what we have discussed so far, by the way, before I proceed. Okay, so the next item in the agenda I wanted to get to, which are, so what are the weather risks we want to address? What are the ones that maybe are important but we want to ignore, and we explicitly say why we would ignore them, and so on. So, I mean, the classic ones are extreme precipitation, extreme heat, extreme cold, extreme winds, and extremely adverse air quality. So these are 5: precipitation, cold, heat, wind, and air quality. Any other risks to coastal communities coming from the air, not from the ocean, that we should add to this list?
Well, I think it's kind of connected to the precipitation or lack thereof. But like dryness isn't necessarily heat, but it is dryness. So like drought scenarios as well.
Yeah, point well taken. I just added it. Yeah.
So you basically see drought.
Well, extreme flood or extreme drought, I guess. Yes.
Yes.
Yeah.
Okay. So, I mean, if we wanted to put kind of a leader to each of these, so let's say, who would like to lead the effort on extreme heat?
Ellie, can I just interject briefly?
Please go ahead, Fred.
One of the issues, though, in breaking it up is that you will miss out on the interdependencies. So I don't know, for example, extreme heat and bad air quality usually go hand in hand. So I'm just thinking out loud that if we sort of break it out into individual components, how do we manage then the reintegration of them? Because a number of like wind-driven rain or something like that could be particularly hard on, infrastructure. So how do we sort of look at the interdependencies and feedbacks then?
Yeah, good point. Any thoughts on this?
And also, you make on that same line, when you think about winds and you're in the coast, then you may think also about surges in ocean surges and things like that.
Yeah. So I didn't mean to kind of break these into 5, but what I want to make sure is that if we, let's say, list these in the proposal, we truly have somebody who can and will look at air quality, let's say extremely adverse air quality, and then how it integrates with heat. I wanted to see if we really have all the expertise we need to address all these individual.
Yeah.
And so, yeah.
I want to make a point also. I want to make a point about even like if we say extreme wind is one thing, but then during these episodes of extreme heat and bad air quality, to understand it's actually kind of along the same lines that Nathan said. Like it's not just like precipitation; it's drought, and using that as an analogy, it's not just the extreme wind; it's understanding the complexity of these really weird, not windy times during heat events in urban coastal areas where the wind flows become so complex that is something, and that is where we're really kind of focusing on that a lot now in our research. So that kind of separates out extreme winds from the understanding the complexity during heat events and air pollution of when the winds are just like doing things that people just, we're going to advance that. Okay.
I think this breaking up stuff is actually okay because, if you look at from an application perspective, I think there are different people who look into there's air quality events. There's different agency that caters for air quality events and different agency that cares for extreme heat and so on. So I don't think we should worry too much about integration right now, but I think I'm with Ellie on let's look at these things kind of individually and see where the expertise are, and then we can integrate it later as we feel.
Ellie, can I ask question about the technology. My impression is that the core technology is going to be a coupled monitoring and modeling system. Is that what you envision as the basic technology that not only the ERC is going to promote, but that would be the centerpiece of what this thrust would address?
Yes, absolutely, Jim. So the next item on the agenda is to discuss the observational and modeling platforms, the ones that exist, and the new ones that we will want to deploy. So
well,
it is.
In terms of looking at the hazards that we would address, thinking of them in terms of the monitoring and modeling technology that would be the core element of the center. That's sort of one important way we have to think about it. Air quality, winds, rain, all of that should be fairly natural in building into the core technology. So focusing on what it is really important.
Sorry, we lost you in the last 10 seconds, Jim. Can you repeat?
From an proposal standpoint, always having in mind what the core technology is that we're going to be promoting. And so as we look at hazards, if it all fits in naturally into this couple monitoring and modeling system, then that's good. We don't want to have things that are just kind of standalone efforts.
Yeah. Point well taken. Okay. So okay, what I can conclude is that I certainly agree with the point that some risks can happen concurrently, and so when they interact, we should look at that. Jim's point was there we should kind of have a system where things kind of integrate naturally in terms of the technology and the observations and the modeling. So we don't want to have an extra risk, maybe for which we would have to deploy a whole different set of models and sensors. With that in mind, and we agreed that basically the risks are extreme precipitation or drought, extreme cold, extreme heat, extreme winds or extremely high or extremely low winds, because extremely low winds will interact with air quality and adverse air quality. Now, so going back to the point, what I want to make sure is that we have a person who can credibly say something about each of these risks. Okay, and in that sense, I'm gonna just propose, so extreme precipitation, I'm not concerned about. I think we have, Jim, Mark, and Reza and others who are quite good, experts in extreme precipitation and extreme precipitation. So that part is covered. Who works on extreme drought? Who's someone we can turn to ask some question about extreme drought?
Well, what I could say is that the last paper that I wrote that has recently been accepted was about the 2015 drought, but that was for the case of the Caribbean, and I can't particularly add a whole lot about the drought scenario in New York City. Although, there are certain things about droughts in general that are similar.
Yeah.
But given that it's a totally different environment, I would like to learn more about it before I can say that without unequivocally that I know,
Okay.
I think, we do have some expertise in CCNY, like Narej. He's not part of this ERC, but we can actually ask him because he does a lot of work related to drought, and he's very, very good.
Yeah. Okay, good. So and I know Jim also has worked a little bit on drought and how hurricanes and droughts and so on. So, okay, we have the expertise. Now, extreme cold is something I've been very interested in. Sorry, somebody was trying to say something.
Well,
No, nothing. I said I will let Naresh know.
yeah, and Reza has worked on drought too. So
Okay, perfect.
yeah, we've got yeah.
Okay, so I've been working recently on extreme cold, and I'm definitely interested in continuing to work on that. Anyone else is interested in extreme cold?
Ellie, can you expand on that and tell me what is it that you're working on with respect to extreme cold? Is
Okay.
it the direct health impacts or other infrastructure impacts? If you can just explain on that.
So it was mainly health and energy impact. So we looked at urban heat island evolution during extreme cold, and what we find is that using observation and modeling in multiple cities, the urban heat island was up to 5-6 degrees and went up to 7 degrees in some cases, which shields citizens of cities, basically citizens, from some of the effect of extreme cold. And a lot of that was related to snow removal processes, which re-establish a lower albedo than the areas around them. But basically, the main thesis is that some of the urban heat island mitigation measures might reduce some of the benefits of UHI during extreme cold. And despite the 2-degree warming, extreme cold is still going to be a main problem for cities at high latitudes. And in fact, it might become an even worse problem if we think that the reduction in the gradient between the poles and the equator lead to more Arctic weather system drifting south. So in that sense, my interest is how does the infrastructure, the building, and the humans deal with extreme cold, and how do we basically alert them to the risks?
The other thing I want to add is in terms of the cities, you could also say during these extreme cold times, the winds make it really harsh. That's one area where you can integrate with extreme winds and cold, because you feel that during the cold period.
Yeah, absolutely. You're right. Yeah. Okay. Anyone else is interested in extreme cold?
Well, in terms of extreme cold, there are a couple of other things that happen. One of them is that the low boundary layer makes the surface pollution typically more severe. So you could have severe pollution episodes during extreme colds.
Absolutely.
And then, of course, the next thing that I would say, I've learned a little bit from the Department of Buildings here, is that these episodic cold waves, for the lack of a better word, creating these freeze-thaw cycles have created serious issues for infrastructure. So rather than just remaining cold and staying cold, how we warm up and cool down, and you have these severe cold Arctic blasts, and then suddenly we warm up afterwards are serious issues with infrastructure health.
I mean, if infrastructure health becomes part of the ERC in an important way, yes, that extreme events and winds, yeah.
I mean, I can take the lead on extreme heat.
Okay. I'm also still interested in that. Anyone is interested in extreme heat? Okay. Extreme winds or lack of winds.
Well, I mean, Ellie, there are people. Ellie, just read that there are people that they do extreme heat at City College. I don't know if you're interested to bring them on board, but because you asked and them, nobody said anything about the extreme heat.
No, extreme heat. Pratap volunteered.
So we already have a victim.
Yeah. Oh, okay.
Yeah, it's also something I cannot see. So, so I think extreme heat is covered. Also, Jorge is some, So extreme heat, heat island is kind of a classic topic.
And
now, extreme wind. So extreme winds, I know that Ning Lin works on that. It's something that she, it's kind of part of the hazards of hurricanes. So Ning works on that. Any other people interested in extremely high winds? and
Well, that's
how they affect
this
coastal.
is
You know,
Mark. I mean,
Mark, you should.
that's
Yeah,
where
Mark.
I'm talking now. Yes, that's what that's
Yeah.
where I say that. But then I don't want to say actually lack of winds. I want to say that not just the high winds, but also the complexity of wind flows, and that's where I'm seeing that. I don't want to call it lack of winds, but at
I think
low,
that what Ellie meant was marked stagnation, which is a problem in LA and sometimes in New York and other places. So,
well,
is that
and then
right,
when
Eric?
the complexity of the winds actually are doing things that are not what like where we can evolve and advance the technologies to be able to better understand, to both observe and model the complexity of turbulent, not extreme winds necessarily, but that extreme winds, turbulent conditions in urban coastal environments, but also the wind shear patterns that do things that are a lot of times very difficult to observe and model, and that's where under low wind conditions, let's just say, not lack of, but low wind conditions, when things get very complex. So I'm definitely going to be on that one.
Okay. Yeah, perfect. So yes, I agree. Especially in coastal areas, coastal cities, you get that kind of interaction between cities, oceans, and rural areas, and the winds. So I certainly hear you about wind complexity, Mark. So okay.
Yes.
So I'll put Mark first, and then Ning as as another person. We can add names later. Okay. Now, air quality. Who do we have anyone who works on kind of extremely adverse air quality?
I kind of look into air quality, and how air quality can affect cloud chemistry and therefore affect precipitation and so on.
Okay.
So we work on air quality from a monitoring and process point of view. I don't know if we have anyone who does the chemistry of air quality, atmospheric chemistry, in our group. But I may not know everybody engaged. That would be a point that I would like to, think about.
I mean, I think, Fred, also to even extend it beyond the chemistry, but to also have as the impact, which is replying to one of the criticism, like who's going to use this system, and to have someone who, I'm not saying we have to have health, exactly. I'm not saying we have to.
Across, Mark, that's sort of across all of these things. The health impacts, could be sort of across all that.
Oh, okay. Well, maybe you're saying that there could be, we do need to have that as.
I think we do.
That's
need to
where
have
we are. That's where we're missing, actually. How do we deliver this information? And so maybe are we saying, have a overarching health component? Is that kind of what you're saying, Fred?
We will have to have some sort of if health impacts is part of what we mean as risks, what is posed by risk, then I think we should have somebody that's knowledgeable about health impacts.
Okay, I'm adding this note right now. So a health expert. Okay, yeah.
But do we have someone who is familiar, who does any kind of atmospheric chemistry work?
So in Princeton, we don't really have one, but in Princeton we do. So I can ask Mark Zondlo, for example, to come on board. We could also ask Denise Mozeral, who's more of a kind of policy and air quality health expert. So we could. So I think we have some expertise in Princeton that we can add.
Okay.
If it's lacking right now.
Mark's experience with the Engineering Research Center would make him
Yeah. I mean, Mark would be also. Mark could help us in case we decide to develop, sensors for some really exotic pollutants or other things that we don't have right now. So we certainly can think of adding Mark. on the chemistry side.
Yeah.
Okay, good. So let's move on because time presses. So okay, so my other thing is my next slide. I hope those on your computer you should be able to see my slide. Was just a little bit of kind of thinking a little bit, on paper about some conceptual issues related to our ERC. So one of the questions that we should, I think, answer is what is special to coastal regions and what is generalizable. I think we certainly can propose to work on general problems that maybe occur on the coast and inland. But also, given the focus of the center, I think we need to outline and define some problems that are specific to coastal areas and basically address them. Otherwise, the coastal in the title becomes a little bit redundant, and that would become something that is, easy to attack. So we need to think about what is specific, for example, within the context of these 5 hazards that we identified. What is specific to coastal areas? So one of the things I noted related to Mark's comment is you get land sea breezes and urban-rural breezes that give you very complex convergence, divergence, and wind patterns. We get, these are what I just jotted from quickly from my own expertise. We get strong gradients along the distance from the coast. For example, the temperature, this is some work that Pratap has done actually, looking at how fast or how sharp the gradients as you move inland become, for example, for extreme heat in urban area. We get high atmospheric humidity that can lead to more rain. City shapes tend to be irregular. So these are some of the kind of specific things that are specific to coastal zones. And what I want is for us to just start thinking about these questions and, how to formulate something that is truly unique or special about coastal areas. So we can leave this for now, or if you have other thoughts about what is special about coastal zones in terms of these hazards, I can add it to the notes right now.
Really, one of the interesting things would be like feedbacks between like different ecosystems and then this coastal forcing. We talk about like how urbanization, urban land cover can impact like the coastal forcing. But also, one thing we should also understand is that we're talking about the whole coast. So there is like all other like wetlands, forest areas, agricultural areas and stuff like that. So it's probably going to be important, like how all these land covers are impacted in this coastal forcing.
That's a very good point, Pratap, because we need also to remember that the title is coastal communities, not coastal cities.
Yeah.
So we're
exactly.
not only limited to cities. Yeah.
Exactly. And particularly in the West Coast, for example, there is quite a bit of like rural population who live on the coast.
Yeah. Point. Good point.
Yeah. Actually, when we talked about the risk, if you think about the West Coast, one of the things that they actually have is like fog situation. That's kind of an extreme situation too, right?
Fog?
The fog. Yeah.
Fog. Yeah.
Yeah, I mean, certainly it can be dangerous to drive. That's a good point, actually. Coastal fog, especially if you get, with climate change, if you start getting more atmospheric moisture in general, it might become advective fog might become interesting. Maybe I'll add that to the weather risks. Actually, that's a good.
Yeah.
Okay. Okay, so that's something to just think about. What is specific to coastal area, and again, going back to one of the comments of the reviewers. Now, as we collect data and develop early warning systems and models, how can we use this information not only to kind of alert, but to think about mitigation and adaptation? That's again going back to the reviews. I think what was an important point. Okay. So That basically concludes the second point in the agenda that I wanted to discuss, which is kind of what are the weather risks. Now, the next point goes back to the technology, which is really the core of this, is what observational, so we'll start with observations. So what observational tools and platforms are we going to rely on? Existing ones and new ones. And so under existing ones, the ones I'm aware of, I listed them. And these would be radars. So this is kind of the existing radars that Jim works with. Who runs these radars, Jim? Is it NOAA or
NOAA?
NOAA, yeah.
No.
Almost all know.
Yeah.
Okay. So NOAA radars, the ground stations of NOAA, the ASOS and so on, all of these things. The ACARS system of airplanes is also something we can rely on.
But it's only like after 60 days or 90 days, so it's not immediate. You can't have ACARS for immediately. It takes about 60 to 90 days for them to put it out there.
So that's the other thing that's important actually to discuss. I had it at the end for satellites. So Jim, are radars almost in real time? When do you get radar data?
You can get them in real time. UR has a distribution system that pretty much is real time, even to academic.
Sorry, Jim. It was a little bit not clear. So not real time, you're saying?
So it is real time.
Real time. Okay, perfect. Does anybody know about ASOS stations, Pratap? Are they almost in real time?
I think they're real time. Yeah, they're real time.
Okay.
Yeah, all NOAA stuff can be obtained in real time.
Okay, perfect. Now, also for you guys who were at Brookhaven meeting a couple of years ago, there was somebody from the New York State who was talking about all the, a New York mesonet.
Yeah, there is a New York State mesonet run by Atmospheric Sciences at SUNY Albany.
Okay.
So that's a bunch of stations throughout New York State. Some of them are enhanced and have wind LiDAR and microwave radiometric capabilities. There are a lot more. I think there are only 13 of those throughout the states. Throughout the state, and then there's a whole lot of
There's about 200, I think. Yeah, there's like 200 other.
I don't remember
stations.
the total, but those are just weather stations, and then a few of.
But they're pretty good weather stations. They have like apart from like they have like they can do like snow depth,
soil moisture, depending on where they're deployed. Yes.
And I remember at least there was one wind LiDAR in Long Island. So
now they have like a 4.
There is one near. There is one near Stony Brook.
Okay. So this seems like a very important resource to add. Unfortunately, in New Jersey, we're poorer. We don't have something like that.
But you do have a state meteorologist.
We do. I can talk to David Robinson, I think.
And but one of the things is like this data is not public data. NY Mesonet is not public.
Yes, but we can buy it, or we can subscribe to it or something.
Yeah, we have access because we collaborated with them. Mark and I can have access to certain amount of the data, specifically around New York City. That's by a MOU that we put in place. But outside New York City, Pratap is right. It's we need to come up with some sort of agreement with the Mesonet to have access to the data.
Yeah, but
and I don't think it's that hard. I mean, we can make
they are trying to get users. Yeah.
I think
but let me also. I would like to make a comment that the industry people who have sold into this Mesonet, that is where I think this ERC really needs to try to focus on serving back to them, because that's the concept of an ERC. What industry, is going to evolve, and they are also concerned, the ones that did supply the equipment for these enhanced stations of the Mesonet. They are very concerned about how their industry is going to evolve. And so, and we have very good relationships with these industry partners as well. And so that is where I think across the whole ERC, we need to be able to have that as our overarching goal. What industry will evolve? So that is a good thing to think about. How to play the Mesonet card is to the industry partners that they also would love to see this become successful.
Okay, yeah, very good point. Now, I know in New Jersey we have some resources. I presume Texas have a bunch of resources if we add Houston. I don't know about Puerto Rico, but I think we should look at the existing state level resources in the different areas where we are. If somebody knows something about Texas or Puerto Rico or New Jersey, maybe they can share the information right now. I know New Jersey has the Mesonet, but nowhere near as good as New York. Go ahead, Jim.
Harris County has a very dense network of range agents. That's Houston, the Houston Austin area.
Okay.
Earlier, you mentioned New York State Network. We also have New York City Metropolitan Network, which is both the MetNet as well as the HydroMetNet.
Oh, I did not know that.
Yeah, I think we have now 23 stations in the city.
Okay, yeah, that's the one that you got. But this one you guys are running, right? So it's almost like perfect. Now
it's real time, yeah.
Yeah. So again, we're listing existing observational platform. We talked about radars, ground stations, ACARS, the local, state, and city level Mesonet, and then obviously there are satellites. So Reza, are these satellites near real time? How long does it take to get?
Yeah,
satellites?
I mean, you can get the NOAA satellite near time.
Okay.
Just the GOES, right?
Yeah, that's GOES. We have antennas on the roof, and we are trying to update it to the new satellites, but we have our own capability to download the data directly from both polar as well as geostationary.
Okay, perfect. So it's plausible that basically satellites would be available to us in real time. I'm not going to delve into the discussion of what exact satellite and satellite products. I think this could probably be significant, but maybe at some point, you guys at City College are the experts, so maybe you can think of what satellite products specifically we want to kind of rely on heavily, and then we can discuss this some more.
Yeah.
Now, the next item is the observational platform, the new ones that we want to develop or deploy. So, an obvious one that we talked about is kind of mobile sensor network. I guess I was thinking of ground-based, but then Mark suggested we can also think of air-based. So I guess here, if anyone has in mind to deploy, acquire, develop, deploy a new system, please share that with us. Go ahead.
So we do deploy research level instruments to the field, which are LiDARs and different kinds of samplers and profilers, and we can do more of that certainly, but it's essentially for field studies that we deploy some of our instruments for wind or other types of profiling, particulate profiling or trace gas profiling to the field. Perhaps for the point of view of ERC, what we can think of whether we need to have sort of a stationary deployments at various locations. I don't know.
Yeah, I mean, so what would be good, I think, is to say that we're gonna deploy these research grade instruments to maybe test some of the other instrumentation, or maybe learn something that would eventually make us able to not rely on the research grade instruments, because if we're proposing a long-term monitoring, these resources should be available beyond the ERC.
Yeah.
And so when we can either think of deploying something and leaving it there forever, or deploying something for a short term for a specific research question, or to learn about, validate other sensors or something of the sort. But certainly, we can think of these shorter term deployments.
By the way, Ellie, one thing that you were missing in available systems in the previous page from the point of view of air quality is the AirNow network of samplers that all the states operate. Connecticut, New Jersey, New York, they have air sampling with different capabilities, and the data is available near real time.
That's
so that's for air quality, that's what we can use.
Perfect. So one thing we could think of is deploying some, low-cost sensors, sensor networks in these areas. Previously, we've deployed them on public transportation buses, and the one thing we are discovering is that the best sensor network will have a bunch of fixed sensors and a bunch of mobile sensors. So if you combine mobile and fixed sensors, you get much more information than with either. And so one of the things I would like to get out of this, ERC myself, at least in the short term, is to deploy kind of a hybrid network of fixed and mobile stations that would measure temperature, relative humidity, and some basic air quality indicators along, in the coastal cities, but also maybe in the kind of outside of the major cities. So any other new platforms that we want to deploy for a very long time or for a short time as part of this? I think this is something we need maybe to think about carefully, because the vision would be to, either on our own or to work with companies to deploy new systems, not only to kind of integrate existing systems. So we should.
Using drones would be a great idea, like for a short-term thing.
Yeah. So that's something I think, Mark was talking about. So we need to be bold, and there will be the resources, because I think overall in the ERC, we Jorge and Masood are thinking of a big chunk of the budget going to new platforms. So don't be afraid to be bold in thinking about new systems that might be useful for us.
Ellie, I would say that one area, aside from the mobile platforms that you were discussing, is offshore platforms. If you're at the coast, for various reasons, you might want to make observations over water, so if you want to invest in something, you may want to think about, that's one of the things that shores have. They have coasts, and you want to do offshore observations for various reasons. So
that's an excellent point, Fred. In fact, then I went back to
one of the things that you can think of, really thinking futuristically, is the impact of wind power, which all of these states are going after, coastal states. And the impact of storms on wind power, impact of wind power on land sea breezes, because they're extracting all that energy from the boundary layer. So all of these things could be discussed within the context of, but then you need to have some platforms, aside from modeling, some offshore platforms.
Yeah. So, NOAA has a network of buoys. I went back and added the buoy network to the existing
so that's
platform.
one of them.
I don't know if they're in real time, but they're pretty good.
Yeah, so there's one of them is that, and we might want to also think about additional observations especially from an atmospheric point of view.
Yeah, yeah, yeah. Okay. Well, please all think about these new platforms. I think, at some point we'll need to think of what do we need to know, and are the existing platforms sufficient, or do we need to add new ones? But we can certainly be bold and go out of the norm in this ERC, because the resources are there. Okay, fantastic. Now, the next item is just one more thing about the tools is that I think we can always think about also developing new, faster communication approaches and new sensors and so on. So, yeah. So the next item was the modeling platform. And I know that all the modelers here use WRF, so that is, I think, something that for sure we will use. And one of the questions that I had is, given that we use WRF and that the National Weather Service uses a slightly different version of WRF, whether we have any connections to the National Weather Service, or whether we can make any connections to the National Weather Service in the context of WRF.
I want to add, so one of our students, like David, he's now working with NCAR, and he's working on HRAM, I guess. I think that's their high resolution fast prediction system that they use.
How do you
the rapid one? Yeah.
It's called HRS. HRRS. Rapid.
Yeah, HRRS.
High resolution rapid
refresh. Rapid refresh. That's NOAA Israel. NOAA system. Research
the NOAA doing that, and he's trying to add the urban component into that system, and they're going to be testing it and see whether how much extra resources that they need and so on. It might not be that hard for us to make it more.
So to answer you, and maybe Jim knows even more than me on this, Ellie.
I don't think the connection would really be to the National Weather Service.
Exactly.
And that we would be looking at industry. It would be something like IBM, one of the industry players that's looking to urban weather. That would be the target.
Okay.
And the key thing to think about in the modeling context is the data assimilation. What is it that we can do? The integration of sensor systems in an urban coastal setting. WRF doesn't really matter so much as a package, but it is a platform, but it's the one we'll certainly use. How are we going to put forward a creative new program for technology that builds on integrating observation?
Yeah, so the integration is a point I'm going to come back to, Jim. I just wanted to first think about, just get a survey of the model people will use. So WRF, certainly in terms of integration, if we don't go after the National Weather Service, for companies we can think of IBM and Vaisala, I think are the two I'm aware of. Any other companies that work in the kind of weather forecasting business we should be cognizant of?
Well, there's every major television station in urban areas.
Yeah, I mean, I listed the Weather Channel, but sure, yeah.
No, but that's
Panasonic.
Plus local channels, okay. Okay.
Ellie Panasonic.
HRRR, 3R.
HRRR.
HRRR, Panasonic, okay. And then
Panasonic. And then Mark, what's the name of that one that Jupiter?
Jupiter Intelligence.
Yeah, Jupiter Intelligence. Yeah, I mean, they're still there, right?
Yeah.
Okay, Jupiter Intelligence. Okay, that's a good list. Okay,
So
so
now I have a suggestion also, and Jim, this reminds me of, I don't know how many years ago that I think one of your students actually went and got a job in the insurance industry after taking a lot of the skills that they learned in their Jim, am I mistaken, Jim, that one of your students actually went into?
Yeah, Willis Reed.
Yeah, and so this is something though that it's come up many times in a lot of different programs that I've been involved in, like the NOAA RESA. Also, they said, yeah, the insurance industry is definitely something that should actually try to incorporate being able to understand the risk due to weather events in urban environments.
yeah, I mean, especially for coastal. Yeah, I think Jim and others have some connections with the insurance industry. I added it to the list. It's something to kind of keep in mind. Okay.
Yeah, Ning has a lot of connections too.
Yeah, exactly. Okay, so in addition to WRF and HRRR, any other models people would think of potentially using? I mean, I listed potentially either DOE or GFDL models. GFDL being in Princeton, we can, look at their models, see if there's anything that's kind of good, worthwhile for us. Other models anyone has in mind? Okay.
I don't think anything comes to the top of mind, but I heard somewhere like, they're going to go into like these kind of adaptive mesh-based models and all these like DOEs pursuing that, and maybe in a very few years of time, like the setup that we are using might not become that relevant.
Yeah. GFDL is going for those, and DOE are certainly going for those. So, I mean, to what extent Brookhaven, I know you guys at City College have been talking a lot with Brookhaven. To what extent Brookhaven is going to be part of this ERC or not?
I thought
I'm not sure.
The person who's collaborating at Brookhaven is Jorge, so I guess you'll have to loop back and discuss it with Jorge. He's spending some time at Brookhaven these days.
Okay, well, I'll talk to Jorge about Brookhaven. I also know that Argonne National Lab has a big group on that. I went there a couple of times, and I'm going back in May. If we want, when I'm there, I can talk to the key people there who do urban modeling with the DOE models, see if they are interested in participating in the modeling aspect of this.
Ellie, the other one is like the one from the Los Alamos National Labs, the quick one.
Yeah, I'm not familiar with that too, but go ahead.
But
in general,
my comment would be it depends on what we're doing in terms of resolution. So WRF would be good to maybe 1 kilometer or so. So if you're going to go to neighborhood scale, you need to have some of the high resolution approaches, urban canopy type high resolution approaches. So we do need to add more high resolution models like Pratap was mentioning.
And particularly for air quality, that's a big deal.
Even weather,
and the atmospheric chemistry into it,
So I mean, we do a lot of LES, building resolving LES of that, but we can talk about that in terms of forecasting. That's a model, to forecast today, it will take you 3 weeks on a supercomputer. So it's not useful in a prediction sense, and it will never be. However, it could be very useful in a bit like, the same way that a research grade sensor is, to understand things and maybe develop better parameterization in WRF, so that eventually you don't need that fine resolution model anymore. But we have that capability, and if we want to add someone who does more of that, I know a couple of people also at Columbia, yeah, but yeah, and Cornell. But so we'll okay. So I'm gonna add LES, building resolving LES, and we'll think about what we want to do with that later. Okay. Now, so my next question is what Jim was alluding to, which is how to integrate models and observations. Any thoughts on that?
You mean, are we going to do like 4D VAR, or are we going to do like nudge our models? Are we going to advance how observations are going to nudge models? Is that your question?
Well, yeah, so that would be one way, is assimilation. The other way is to do some assimilation, but then also later take, observations and models and fuse them into a mixed output that you would use in one way or another. What are, who works on that? What are ideas you guys have? What are you interested in trying in that sense, and so on?
One aspect is validation, right? So utilize observations to validate the models.
Yeah.
And utilize the models to validate the advancements of observations.
Okay, so cross-validation, I guess, is
I mean, both. I'm saying that, and then when you do that, then you can actually start dabbling in the ability to do assimilation.
Yeah. So one thing that's going to be important is model data fusion. You get the data separately, and then you want to basically produce a map of floods or a map of heat. And the question is, how do you fuse them to produce this high resolution map? So then you can either basically communicate it to the citizen or make decisions based on this kind of fused data. So so data fusion beyond just assimilation or validation is something that we should be thinking about. I think, given that the output that really we are proposing is kind of an early alert system. An early alert system has to be able to get data from both sources independently and make some alert decision based on that. Do you guys know anyone at Princeton or City College or somewhere else who does this sort of data fusion? Do we have anyone?
In terms of data, visualization, we just hired a new ComSci person who does multidimensional data visualization. I don't think she's on this call,
but she's part of the ERC.
Well, yeah, she's part of the ERC.
What's her name?
But I think the data assimilation, though, that's a different thing. She doesn't do data assimilation.
No,
visualization.
Yeah, she does visualization.
So visualization is important, but my thought was fusion, even before visualization is, so you have a location where the model tells you the temperature is going to be 30 degrees. You have a sensor that tells you the data is 32 degrees. Which one do you trust? How do you combine these two products into a single product on which you are going to make decisions? It's a bit like geospatial statistics in some way, and we've been working a little bit on that. But anyway, so visualization is certainly, after that you need visualization. So, yeah. Okay. So I think, I'm noticing we probably should move on actually, because we have 12 minutes technically left. But it seems like for the modeling and the model observation integration, maybe we need to think a little bit more on this. Now, so the last thing I want to get to today is what are the science questions? Because even though this is an ERC, and it is basically about developing new engineering tools and platforms, this is still NSF, and one of the comments in the reviews is that, okay, what are the science questions? So what are the science questions?
Are we talking about the science question for this group or the whole ERC science question?
Well, in a way, both. So if you have something specifically for this group, or how the work of this group links to the other. So I think for now, maybe let's focus on this group. But certainly, if you have suggestions of higher level questions for the whole ERC, definitely go for it.
Because on the pre-proposal, I thought there was some science, maybe not an informal science question, but there was informal science approach or some science objectives.
Yeah, I think one of the reviewers noted that we need hypotheses or questions, or I don't remember if they said the hypotheses or questions, but
they said hypotheses.
Yeah. So we need to think about either the hypotheses or the questions or a mixture of both, because in the end of the day for NSF we need to show that we are advancing the state of the science. And so one thing that comes out naturally if we, given the discussions, some of the questions that come naturally is related to the complexity. I'm trying to write as complexity of wind patterns, the synoptic scale, variability of coastal weather.
Mm-hmm.
Data assimilation and fusion.
Okay. And also some fundamental questions like, what scale do we observe and what scales in, that we forecast?
Ellie.
Yeah. Yeah.
Can you expound on that point a little bit? The synoptic scale, what was it that you said? The synoptic scale effect
the synoptic variability of coastal weather. I'll tell you more what I'm thinking of. In the urban field, we've been kind of, we stick to this idea of urban climatology, which is fantastic. Oak started it. But the reality is, if I tell you that the urban heat island in New York is 3 degrees, it's useless because it's never 3 degrees. One day it's 1 degree, another day is 5 degrees. So one of the questions I want to work on through this ERC is what controls the day-to-day variability of urban heat islands and coastal weather. Why, on one day you have something and on a different day you have something else. So this kind of, if you want coastal weather, what controls coastal weather day-to-day variability?
Mm-hmm.
Well, that is it.
And also,
That's question.
another thing too is a lot of times when people from the weather people, when they do a lot of these forecasts, they are mainly concentrating on the large scale systems that cause these impacts, which is mostly fine. They think this is the most dominant processes, and they're going to run over all the other things. But I think maybe we could also say how much the local ecosystem or the local land cover in general impacts the system, and they could potentially change the dynamics.
Exactly. That was exactly my thinking, because that's why Ellie's suggestion struck me automatically when I heard it, because yes, the large scale or the synoptic does impact.
So the microclimate you guys are talking about.
Exactly.
The microclimatic conditions.
Right.
Okay. Yeah. So coastal microclimate. Okay, good.
Exactly.
I think the one thing that our science question should move. What does NOAA cannot do that we can do?
That's
because
very
some of those things NOAA can do it, and so we want to kind of emphasize on what would be the value added for us. Otherwise, they're going to review, going to say, okay, NOAA is doing these things, so what's new? I think the integration of the models and the observation is something, and also the variability, the short-term variability.
Yeah, but that's a very good point in general, Reza, is that we cannot be a forecasting center purely because NOAA is already doing that.
That's what I'm saying. Actually,
exactly.
I put it in different. What can we do that NOAA cannot do?
Exactly. I wrote this comment. It's very good. Yeah.
Yeah, it's the other way around. That we have to say, what can we do that they don't do?
Oh, sorry. What does NOAA? Yeah, I missed the question. Okay. What can we do that? No. I understood what you said, but I mistyped, so I corrected it.
Yeah, okay.
Often NOAA is, Reza, you hear this all the time, I think, is that NOAA always is criticized on how they're not delivering their products to the users because they need to have better social scientists, right? I mean, you hear that a lot, right? Right. Or we need to work more with social scientists so that we can understand how the, as NOAA CREST delivers, helps NOAA actually. But is it? I don't want to say social scientists. Actually, I say that we hear that a lot, but it's actually decision-making processes. I think is really where NOAA, because they are a government organization, I think they cannot they're kind of constrained to have an automatic decision-making process of their system to go into like an industry decision-making automated process. Right. But maybe that is something that they can't do because of some constraints. Is that correct? Do you think, Reza?
Yeah, I agree. I know, especially that when it comes time to explain the weather risks, I mean, we should focus because mostly does the monitoring and maybe forecasting, but when it comes to risk, so they are not doing a good job in terms of assessing it with risk attached to it.
So I added
that's something. Yeah.
Sorry, Reza. I added a category. I called it questions on adaptation and resilience, question related to decision making, and linking of atmospheric and oceanic hazards.
Okay.
Yeah. So again, we need, as we go forward, I think we need to coalesce on some thrust-specific questions and overall questions. And again, I think Reza's point is extremely important. Ones that basically go beyond the mission of NOAA or other agencies.
Correct.
Yeah. Any other thoughts on the science questions?
One other thought on the science question, that is, obviously about extremes and rain.
Sorry, Jim, I can't hear you well. Can you repeat that?
Of extremes, and I'm thinking specifically of rainfall extremes, how they vary over land relative to coastal structure is very poorly understood, whether it's convection or tropical cyclones, and for all of these hazards.
So Jim, sorry, I can't. The line is not very good. I'm gonna send you an email, maybe to email me that thought, and I'll add it to the slide later because I cannot hear you well.
It sounds like he started to talk about the comparison between convective processes over land and over the ocean, and the differences that are inherent within each.
Yeah, that's also what I gathered.
Yeah.
Go ahead. Yeah. Okay, yeah. That's a good point. How do extreme systems evolve as they go, from ocean to land or vice versa? I mean, tropical cyclones certainly evolve significantly. Okay. I know how to catch Jim later and clarify this point even further. Any other thoughts about the science question? I think technically we have 2 minutes left, and so we'll talk again. But so any other last thoughts about the science questions, or maybe items we should have discussed that I did not include on the agenda?
One general thing would be like how whatever that we are doing varies, for example, in the mid-Atlantic area, in the Gulf, and in the tropics.
Yes, that's a very good point, Pratap. So
Yeah.
regional comparison between regions.
Yeah, and also the West Coast and the East Coast, because the systems are very different.
The problem is I don't think we have a West Coast observatory. So, I don't know.
As long as as long as we are relying on some of these data from NOAA and National Weather, like all these ASAS, like publicly available data, we might be able to, have a better understanding of what's happening on the other side.
So
as long as it's constrained. Yeah.
Yeah. So that's a good
And we could write the proposal, as we discussed earlier, as that we can go into campaign mode and test out this area on the West Coast and then that area on the West Coast, as more of a campaign mode.
Yeah, that's a very important point. To what degree can we go out of our test bed, and how do we do that? I think we should discuss it with the other thrusts as well, so we have something coherent. But if we can do that, I think that would be actually a plus. Okay. Yeah. Okay. Sounds good. So thank you, everyone. So please, I sent you a link to the slides. Feel free to go in, add thoughts, add comments, add questions, and so on. This is a sharing. This is a shared document. We can all edit it, and then we'll follow up with a next Skype for this group specifically at some point. I guess in the next few weeks, in addition to the ERC-wide meetings that will happen.
Yeah, there's one tomorrow.
Yeah, correct. Yeah.
All right.
Okay, thank you, everyone. Thanks a lot. So, Pratap, please share with me your notes, and I'll.
I will send it to you later today.